What's going on, everyone? It's Brace from LangChain, and in this video we're going to be implementing a full stack Stockbroker human-in-the-loop agent, including a LangGraph backend, which we're then going to deploy to LangGraph Cloud in production at the end of the video, as well as a front end written in Next.js. So this graph we're going to be building is a Stockbroker agent, which has some human-in-the-loop capabilities, where our agent can fetch details from financial APIs. If you're on Twitter, you're probably familiar with Virat. We're going to be using his Financial Datasets API to fetch data about different public companies and then also prices of stocks. So big thank you to him for building out this great financial data API. So our agent has a series of tools that it can call around getting the current price of a stock, getting some revenue reports or some different data that these public companies have to disclose so that our agent can make informed decisions about purchasing stocks. It can then also prepare purchase details if we ask it to purchase a stock. And then the human-in-the-loop portion is before it executes the purchase. If the purchase confirmed field in our state is not set to true, then it will throw a dynamic interrupt our graph, and we will have to set this field to true, or else the purchase will not be able to go through. These purchases are just mock stock purchases. They're not actually executing purchases, but it works pretty much the same way, minus the execute purchase API call you'd make if you were to build this for production. So we can try out a quick message here saying, what is Google's current price? And on the right, we see all the events stream in. So we see our LLM called the price snapshot tool. The price snapshot tool returned Google's current price, and that got sent back to the LLM where it generated a plain text response saying Google's current stock price is $157. We can add a new message saying, let's buy 4 shares. When we submit that, it called the purchase stock tool. That then got routed to the prepare purchase details node where it prepared all the purchase details. And before it could execute the execute purchase node, the graph was interrupted. And this is because purchase confirmed is not set to true. If we inspect the current state, we can see that we have our messages in our state, our requested stock purchase details object, which is what the execute purchase node needs in order to actually execute the purchase. However, purchase confirmed is not present. So if we check this box here and then update it to execute this as the prepare purchase details node, so the node that just ran, and resubmit, then now purchase confirmed will be true and it should be able to execute the purchase, and the LLM should tell us that it executed the purchase. So we hit submit, we see purchase confirmed true, and then our LLM called the execute purchase node where it returns successfully purchased 4 shares of Google at $157 a share. Now, if we were to create a new thread and say, what's Google's current stock price? Submit it, and then once this goes through, we can say, let's buy 4 shares, or let's not set this to true, and instead, let's say let's buy 4 shares. We hit submit. It then obviously will not be able to execute the execute purchase node because purchase confirmed is not set to true. And then if we try and continue it, since purchase confirmed is not set to true, it will never be able to execute this node, which is exactly what we want. So we can see, doesn't matter how many times we click continue, it is never able to execute the purchase. It also doesn't matter if we send in a new message saying execute the purchase. We have to explicitly set this field to true. We can send in a new message, and as we can see, it did not work, even though it updated the state at the end to include that. It is just unable to call this node because of our node interrupt, which we throw if purchase confirmed is not true. So now that we have a good high-level idea of how our graph works, let's go jump into the code and see exactly how each node works. So to follow along, you're going to want to clone the LangGraph.js examples repository. I'll add a link to it in the description. And then once you've cloned that, navigate into the Stockbroker directory. I already have it cloned, so I can open it up. And as you can see, the Stockbroker directory is formatted in a monorepo-like way, where we have 2 projects, backend and frontend, inside of our directory, and then a root package.json and a turbo.json file because we're using turbo repo to manage our monorepo. So to install dependencies for Stockbroker, you can just run yarn install from the root of the Stockbroker directory, and that will install all the dependencies you need for the backend and the front end. And then once you've done that, you can navigate into backend and index.ts, where we have the code defined for our Stockbroker agent. So as you can see at the top of our file, the first thing we define is our graph annotation. This defines the state of our graph and the different fields which we can return and pass through to each of our nodes. We are importing the messages annotation state object from LangGraph, where we spread that, and that essentially adds the messages field to our state. And this is of type base message or a list of base messages. And then when you return a message into the state, it gets concatenated to the current state with a little more logic around adding and removing messages. The next field we have is the requested stock purchase details field, and this is of a type ticker quantity, and max purchase, and this contains the fields which our prepare purchase details node generates, so that when we want to actually execute the purchase, we have exactly the fields that we need to execute that purchase. Finally, we have purchase confirmed, which is a Boolean, and this is the field we use to determine whether or not a user has actually confirmed a purchase. We're using GPT-4o for this, but you can use any LLM you'd like. And then we pass all of our tools to a tool node. A tool node is a built-in class that is exported from LangGraph, where you can pass in a list of tools, add it as a node, and then anytime that node is invoked and it's passed an AI message from an LLM that contains a tool call, it will map the generated tool call to one of the tool calls you passed in, and then invoke the function on that tool call. If we inspect this list, we see we have a web search tool, purchase stock tool, and then a series of other tools from the Financial Datasets API, which allow us to get things like the current price, some company facts, and so on. We can inspect the purchase stock tool, for example, and as we can see, it's a simple LangChain tool that for the function, it just returns a string saying, please confirm you want to purchase this many shares of this ticker at the purchase price per share or the current price. The schema contains ticker, company name, quantity, and max purchase price, which are all optional. We'll get to why these are all optional when we inspect the prepare purchase details node. And then all of the other tools are built pretty much the same way. However, the ones which call an API have this call Financial Datasets API function inside them where they are actually hitting the Financial Datasets.ai API. So that's the tools which we provide to the model, and then the first node we have is call model. This call model maps to the agent node. If we scroll to the bottom, we can see in our graph we've defined the agent node with the call model function. And then every time we start, we will always map to the agent node, and that's what we can see right here. Start always goes to the agent node. So if we inspect this node, we can see it takes in an argument of state, which contains all of the fields in our state. We extract the messages, and then we define a simple system message, just saying things like you're a financial analyst, you can do XYZ, you have a series of tools provided to you. We then bind all of our tools to the LLM so that our LLM can actually invoke the tools that will need to be routed to the tool router, prepare purchase details node. And then we invoke the LLM, always passing the system message as the first message, and then the rest of the message come after. Finally, we return the result to the messages field, and then our messages annotation state object will handle concatenating this new AI message to the rest of our messages in our state. We can see we've defined a conditional edge here, which always occurs after the agent node is invoked. And that's why our agent node has all of these dotted lines coming out of it, or dotted arrows, sorry. These dotted arrows indicate a conditional edge that this node can take, so it can either go to the tools node, prepare purchase details node, and so on. And we can see the different options that this conditional edge can take are the tools node, it can end, it can call the prepare purchase details node, and finally it can call the execute purchase node. So if we inspect the should continue function, we see it also takes in a state argument as the first argument, and the type of it is the graph annotation we defined. And then we extract the messages, requested stock purchase details field from the state, and we make sure that the last message is either an AI message, or if it's not an AI message, we return, and if it is an AI message but does not have tool calls, we also return. So we return this special end variable here, and that will essentially map our agent to the end. So if there were no tool calls called, or if it was, say, a human message somehow made it to the last message in the list, then just return because there's no more actions for the agent to take. Next, if you have populated the request stock purchase details field, then we want to map to the execute purchase node. That's because if this field is populated, that means that there is a stock purchase which the user is trying to put through. So we want to map it to this node so that I can execute the purchase, or it'll be interrupted if you have not set purchase confirmed to true. Then we extract the tool calls from the message and throw an error if none exist. And then finally, we iterate over all the tool calls, and we say if the tool name is purchase stock, so if they called this purchase stock tool, then we want to route to the prepare purchase details node. And if it's not, route to the tools node, which has access to all of the different tools we defined, and it can invoke the functions on those tools. We want to route to a special node for the prepare purchase details function because this contains some extra logic that doesn't live inside of our tool. So we've seen the call model node, we've seen the tool node, and we've seen our conditional edge for the agent. Next, we can inspect the prepare purchase details node, and then finally the execute purchase details node. So for the prepare purchase details node, which is this node we see right here, once again, it takes in the state, it extracts the message, and if the last message is not an AI message, throw an error because that's unexpected. Next, we look for the purchase stock tool call. If it does not exist, throw an error, because once again, this should always exist if this node is being called. Then we extract the max purchase price, company name, and ticker fields from that tool call. So this tool call is going to use the context in the message history, or if the user just said, I want to buy, this many shares of this company for this price. It'll extract those and then pass them to the tool where we're given structured output like we see here. Then, if the user does not define a ticker, see we allow for a company name and a ticker. If they do not define a ticker, we then check to see if they define a company name. If they did not define a company name, then we want to return early. And as this comment states right here, since the last call was a tool call, we will always need to have a tool message follow that tool call. And that is because the OpenAI API simply does not allow for messages which are not tool messages to follow AI messages which called tools. So we just return a tool call or a tool message saying, please provide missing information. And then we provide an AI message saying, please provide either the company ticker or the company name to purchase a stock. Since this is an AI message with a string content and no tool calls, it'll just get routed to the end, and that will tell the user you need to provide either the company ticker or the company name. However, if they did define a company name, then we can pass it to the find company name function. Essentially what this function does is it takes in the company name, it calls the web search tool, which is powered by Tavily, to search the web for the ticker for this company name, and then we pass the search results of the Tavily search results tool to an LLM with a simple structured output tool bound to it, saying extract the ticker from the search results, and then we return the ticker. Next, if the user did not define a max purchase price, then we're going to invoke the price snapshot tool, passing in the ticker, because the max purchase price defaults to the current price if it's not specified, and then we assign the max purchase price variable to the result of the price snapshot tool call. Finally, we return the requested stock purchase details object, and that's what our execute purchase node needs in order to execute the purchase, passing in the ticker, the quantity defaulting to 1, and then the max purchase price. Next, we see we have the execute purchase node, and that's this one. The first thing we do is we extract the purchase confirmed Boolean field and the requested stock purchase details field from the state. If you have not defined your requested stock purchase details, we throw an error. This should never happen because this node should only ever be called after the prepare purchase details. But if somehow it is called, we want to throw an error because you cannot purchase a stock if you don't know what you're purchasing. Then we check for the purchase confirmed field. This is important because here we're throwing a special type of error, node interrupt, because if you have not specified purchase confirmed true, right, if this is false, then we need to interrupt the graph saying please confirm the purchase before executing in order to allow the user to set purchase confirmed to true or false if they don't want to confirm it. This is so we can't just say the LM buy 4 shares and then it goes through and just buys these shares right away without letting us confirm. So if purchase confirmed is not true, we're going to interrupt the graph with this special error here, which we can throw inside any node. And that will interrupt the graph like we saw in the studio, allow us to update the state, and then it can continue. It's important to note that in the real world and production, you're probably going to want to have some sort of two-factor authentication here instead of a simple Boolean field where the user adds some two-factor authentication code, and then in your backend, you validate that code to ensure that they actually are allowed to confirm purchases. But in this case, we just have a simple Boolean field because we're not actually purchasing stocks. So if all of this is defined, then we execute the purchase. In our case, it's just returning a new message, an AI message saying successfully purchased this many shares at this price. Once again, since it's a text message, it will get routed back to the agent where the agent will say, okay, it's an AI message and there are no tool calls, so route to the end, and then that will finish the graph. Now, let's inspect our LangGraph.json file. This is where we define all the configuration for running our graph in the studio and also deploying it to the cloud, which we'll do in just a second. We can specify things like the node version, we can customize our Docker file, the dependencies. In this case, I just said to look inside this directory and install the dependencies inside this directory. And then our graphs, we only have one graph here, Stockbroker, but if you are building a larger application, you can define as many graphs as you would like. And then finally, we define our environment variable file, and this tells the studio for local development where to find our secrets so it can actually invoke our node that require these specific API keys. Okay, so now that we've looked at exactly how our graph works, we can go and deploy it to production and then hook it up to our front end and run it and see how it would work with a chat-like interface. So to deploy your graph to production, you're going to want to go to Langsmith and then to the Deployments tab and click New Deployment. Here, you can link your GitHub repository if you've not already linked it. And once you've done that, you can select a repo from the dropdown. In my case, it's going to be LangGraph.js examples. And then you want to give it a name. So we'll use the default name for now. And then after that, you want to specify the path to the LangGraph API config file. And this is the path, or this is the file that we were just looking at a moment ago. And in our case, it's going to be nested inside of the Stockbroker/backend directory. So when we've updated that path, our cloud deployment will actually be able to find the proper LangGraph config file and all the different configurations we've stated. Next, you can specify a Git branch if you want to customize that. In our case, main is fine. And then a deployment type. So if you're going to production, you're obviously going to want to select production here. But for us, just development is okay. And then your environment variables. This is where you would add your Financial Datasets API key, your Tavily API key, and your OpenAI API key. You do not need to add a Langsmith API key because LangGraph Cloud will automatically create a new tracing project just for this deployment. And then all the different Langsmith runs and events that occur inside this production deployment will automatically get mapped to this project. And the API keys for this project are injected right to your deployment. So there's no need to specify any sort of Langsmith API keys because we do all that for you. When you're done, you hit submit. And then when your deployment is finished, you can open it up like this. Open up the deployment page right here, and you see a bunch of different things like your tracing project, the repository, which this was loaded in from. This is the production API URL, and it's how you'll actually hit your API. And then you can see things like the different runs which were invoked using your production endpoint. So we can inspect all of these just like you would if you were, say, looking at your runs inside your projects from the projects page. You can also check out the different revisions. A revision is essentially when you make a change to your code, you need to trigger a new revision by clicking new revision here, and that will redeploy your app using the new code. You can also open it up in LangGraph Studio, and this looks pretty much the same as the LangGraph Studio you're running locally. However, this is connected to your production endpoint, and you can interact with it the exact same way you would using the local version, but of course this can hit the production endpoint. So now this is done, we can copy our API URL and then navigate back to our GitHub repository, go into the front end directory, and then you're going to want to copy this environment variable example file and create a new .env file using your actual secrets. So LangGraph API URL, that's going to be the API URL that was generated in your deployment. LangChain API key, you do need this in order to connect to that deployment. And then the next public LangGraph graph ID. This is going to be the name of the graph that you defined in your LangGraph.js. So in our case, it's going to be Stockbroker. Once you've defined all those fields, you can run yarn dev inside of the front end directory and spin up your web server. So we can do that right now. See, I open up my terminal. I want to navigate into the front end directory, and then I can run yarn dev. It's going to spin up a new deployment, or a new web server, at localhost 3000. I can open that up, and then we'll see our UI is loaded. We've preloaded in some questions like what are some facts about Google, how much revenue did Apple make last year, and so on. But we can just submit a question like how much revenue did Apple make last year? This is going to call some tools. So we see it called the income statements tool, passing in the arguments of Apple's ticker, the period of time in which to fetch the income statement, and then the limit. And then finally, it generated a response saying Apple made $383 billion in revenue last year. We can also click show result here. And this shows us the result of the tool. In this case, it's the result from the Financial Datasets API that was invoked by our tool. And this is how our LLM was able to generate that context. Now, if we want to say, purchase some Apple stock, we're going to ask it what the current price is, and then say purchase. And since our graph will be interrupted, we'll see a similar UI to what we saw in LangGraph Studio, allowing us to say confirm or deny. So for purchasing, I've created a new session here, and we can send a message like, let's buy 4 shares of Apple for the current price. We'll hit submit, and it should call some tools. See, it called the price snapshot tool, which got the current price of Apple, passing in Apple's ticker. And then it called the purchase stock tool, passing in Apple's ticker, the company name, the quantity for, and then the max purchase price. Since our graph was interrupted, we get this message here saying graph interrupted. The next node is the execute purchase node. And then also our input is disabled while our graph is interrupted. So if we want to confirm, we can say confirm purchase and then update state. This is going to make an update state API call to our LangGraph production deployment, updating the state so that the purchase confirm field is true for this thread. And then once this is done, we can continue. And this is also similar to the UX you saw in the LangGraph Studio, where you hit continue, and it continues from where it left off in the graph. So we see state was updated, and once we hit continue, it should purchase the stock for us. So we say continue, and then successfully purchase 4 shares of Apple at $220 a share. So this worked exactly as we intended. And obviously in production, you're not going to want to have a simple checkbox the user can check. It might want to be, like I said earlier, some sort of two-factor authentication. This is how you'd implement a full stack LangGraph and Next.js app, deploy it to LangGraph Cloud in production, and then hit your production API using a Next.js frontend like this. We can interact with our production server using a chat interface. I hope you guys enjoyed this video and know some more about human-in-the-loop applications and LangGraph, and I'm excited to see what everyone's builds.